Welcome to the making of a real-time strategy game, part 5. We have previously made an electrical grid, a truck logistical system, flocking for movement and aggro for the robots, and a lot of weapons. We start this video with a question. Most real-time strategy games have an upgrade building, which require resources, plus you probably have to upgrade your main hull first or something like that. Almost magically, after researching an upgrade, all the units get it. Some turn games, like Civilization, after an upgrade is available, the unit goes back to its territory and can be upgraded with money. Some, like Masters of Orion, units have to go back to the factory. Some, like the 2 Points Hospital and Campus series, after experience, the unit goes to a training room to be upgraded. What will it be in this game? Well, you're going to find out in this video. Buildings now draw aggro and require power to power their shields. Grid maps are added to the game to tile the ground. At this point, it's only to test it. Once again, I am stuck and do not know the next step. Mechanically, I need a way to make weapons. Most games allow you to stay near your base to build weapons or units and upgrade them. I want the player to go and explore the map and get items in order to develop an economy. I also wanted the economy itself to require resources, just like the tower requires power. I also needed an upgrade system. I was thinking of Warcraft 3, something with cutting down trees and the world tree. And then I thought, why not grow trees? It made sense. First, you have to find trees, then you could plant them, and then you have to grow them with water, time, and fertilizer. After which they will have fruit, and you can make that into weapons. The trees can also be upgraded. This fulfilled all the missing mechanics and led to the theme of the game of it being in a garden. This later led to the idea that the garden would start brown and then be transformed to green. When I started development, I only had an initial premise, but I had no idea what I would implement. As with the power grid idea, I only got the tree mechanic after I asked a question. There's a repeating pattern here. Till I got to the place where I can ask an interesting question, only then can I come up with an interesting answer. It took many days to implement the trees. I made the watering truck in Blender. I made a system where you could use the grid map to decide where you could plant the trees. This, of course, was later changed. I made the trees grow with the watering truck. I made a vacuum truck to vacuum the fruit on the trees. And I had to make a way of getting seeds. This took quite a lot of time, and I would imagine a lot of time was spent trying to figure out what to do next. There is a fruit stand building, which is used to store seeds and fruit, but later on I decided just to use a silo for this. We finally have an inventory system working. A single item is a resource. The RTS resource class contains a dictionary of resources. Each RTS model has an RTS resource for inventory. Work continued on the inventory system. Inventory can now be transferred using a menu system. There is a dead tree which stores seeds. This can be edited in the map editor by using export in the code. Currently, only one enum category is there. Later, I would split this into categories. Build formulas are also RTS resources. And pictures are automatically loaded if they have the same name as the item in the correct directory. The weapons factory is created. There's a significant improvement in the building models from the original power plant to the geothermal plant onwards. Since the structure of the code for the building is made, the only code that is required per building is essentially what items are in the to be manufactured list. Also, there is some code required for how the animations of each building work. It will now be quick to add additional production buildings to the game. The inventory now splits the IDs based on the category. The directory system or the file system of the game is not in its current form. Later, each category gets its own directory. The truck factory has a new model, and it now works with the menu system versus using some kind of HUD system. There is now a new marshaling system for truck deliveries, which makes more sense than what was done before. An order is placed, these items are then reserved in the silo, and a delivery truck is summoned to pick them up to be delivered. A new building factory is made using the menu system now versus the HUD approach. A new building truck is made, significantly improving on the previous design. The truck has a crane that is animated procedurally in the code versus animation from Blender. The animation uses a state table. There are 3 functions to perform the basic movement: raise the height of the crane, rotate the crane, and extend the crane. These can be programmed to any arbitrary distance. The state table is used to call these functions in order to perform the animation. The building is actually created during the initial mouse click in order to reserve the space. There needs to be a way that the turrets can be loaded with weapons and then later upgraded. The building truck is used to do that by transferring inventory using the menu system. Later on, it was simplified to dropping weapons on top of the building using an action button. The trees can now be upgraded, which can then be used to make upgraded weapons in the weapons factory. The directory system was refactored to split the code and the assets. The code is now in the code directory, and the assets are now in the asset directory. Each of those would have a directory that is the same name as the RID category. The thumbnail will be automatically available if they are in the correct directory. After a tree is upgraded, it produces more fruit per level. The drop system drops items when a robot is destroyed. However, the grid system only allows 1 item per grid space, so this limits how the drop system would work. So a quad tree is added so that it can contain a list, or in this case, a dictionary of items contained in a space. That allows items to be overlapped. I decided to use an occupancy grid since I developed this game in C# and just in case I needed any speed increase. It was not realized yet at this time that using a quad tree, which allows overlapping, would significantly speed up the physics, and overall would be quicker than the occupancy grid. In hindsight, it's hard to believe that I ever used an occupancy grid in this game. A new power plant, the ethanol plant, is added to the game. Its resource corn is added and harvested with the harvester. Using the same code, hemp or metal is also added to the game. Robots no longer draw wheat, and coal is removed from the game. For now, the inventory menu system is used for a power plant to call for delivery, just like any other production building. Later in development, push-button delivery is added. The engineering building is created. If you're wondering why in the final game, the weapons building has so many items in its to-build inventory, and the engineering building has so few items, well, when I was developing the game, originally the engineering building has many more items, but I decided not to have them in the game so far. The egg tree is created for the animals in the game, such as a goose or the dog, but once again, it is not used in the final game at present. The nuclear plant is created. If you're wondering what the animation is supposed to be, it's the atomic symbol. Quite a lot of progress was made this month, which started with very few buildings with poor models and no inventory system. Now there is a functional game economy with an upgrade system. It is now starting to look more like a video game. Well, at least the new models. The older ones will get new models eventually, and there's still more to be made. Thanks for watching.